this video, we will try to solve the roots of the quadratic equation by the use of extracting the perfect square roots. Now, for us to understand the extracting the perfect square roots, let us recall first our knowledge on the standard form of the quadratic equation, which is ax squared plus bx plus c is equal to 0. Now, if b is equal to 0, then we can now reduce our equation to ax squared is equal to c. If this is the given quadratic equation, then we can use extracting the perfect square roots. But this question is, how? So to understand extracting the perfect square roots, we have to remember first square root principle. First, if x squared is equal to c, then there are two values of our x or roots of our equation. The second one is the radicand c should be greater than or equal to 0. Now, for us to understand all this square root principle, let us apply this in an example. X squared minus 36 is equal to 0. The first thing that we are going to do if this is the given is we will isolate our variable in the left side, and this number should be transposed to the other side. That gives us x squared is equal to positive 36 because negative becomes positive as you transpose to the other side. Now, recalling our square root principle, if x squared is equal to c, this one, then there are two roots of our x. So therefore, we have x is equal to positive negative square root of 36. And the square root of 36 is of course 6. Therefore, our answer, the values or the roots of our x is equal to 6 or x is equal to negative 6. Now, for you to check your accuracy, you can actually check if x is equal to 6 and if x is equal to negative 6. Now, let us have another example. Let's say p squared is equal to 49. Now, since our variable is already isolated in the left side, we can already use the extracting the square root principle. So we have p is equal to positive negative square root of 49, and the square root of 49 is 7. So there are two values of our p, which is 7, or p is equal to negative 7. Another example, let's say 3m squared is equal to 24. Now, if you're going to look at the left side of the equation, our variable is already isolated. But if you notice, the variable or the coefficient of the variable is 3, that is more than 1. So we have to remove first 3. And how to do that? Of course, we are going to divide both sides by 3. And we eliminate 3, that gives us m squared is equal to 8 because 24 divided by 3 is 8. Now, applying our square root principle, we have m is equal to positive negative square root of 8. But since 8 is not a perfect square root, so what we are going to do is we are going to factor 8 with its greatest perfect square. So what does it mean? We will look for two factors of 8 that one of each factor is the greatest perfect square. And that is, of course, 4 times 2. If you notice, 4 times 2 is equal to 8 and 4 is the greatest perfect square for 8. So, getting the square root of 4, we have positive, negative. Square root of 4 is 2, square root of 2. So, there are two values of m, which is m is equal to 2 square root of 2 or m is equal to negative 2 square root of 2. Another example, let's say 2 times d minus 5 raised to the power of 2 equals 32. Now, if you're going to look at our equation, it sounds complicated, but no worries. What we are going to do is we remove first the coefficient, which is 2, because 2 is more than 1. So we have to remove by dividing both sides by 2. Eliminating 2, what is now left is d minus 5 squared. And 32 divided 2 is 16. So getting the square root in both sides of the equation, eliminating our square root in the left side and the exponent 2, what is left now is d minus 5 is equal to positive negative 4 because 16, square root of 16 is of course 4. Transposing negative 5 to the other side, we have d is equal to negative 5 becomes positive 5, positive negative 4. So there are two values of our d. We have d is equal to 5 plus 4 is equal to 9, and d is equal to 5 minus 4 is equal to 1. So our values for d is 9 and 1. Let's now have the fifth example. N squared plus 9 is equal to 4. Now, if you notice, we have to isolate first the variable to the left side, so we will transpose 9. N squared is equal to 4 minus 9 because positive 9 becomes negative 9. So, n squared is equal to negative 5. So, our variable is already isolated, so therefore, we will apply na the square root principle. So we have n is equal to positive negative square root of negative 5. Now we have to remember our square root principle. It says that the radicand c, which is inside the radical symbol, should be greater than or equal to 0. In this case, it's negative 5 and this is less than 0. So if this happens, guys, what you're going to do is just write no solution and proceed to the next number. So I hope you have understand our lesson for this session. Um, if you have some questions and clarification, you can always write your comments in the comment section. Now, for your practice worksheets, in solving the roots of the quadratic equation by the use of extracting perfect square roots, I have prepared already a Google Drive link. It is in the description box below this video for you to download the practice worksheets. That would be all for this session. I hope you like our presentation, and please don't forget to subscribe to my channel and click the notification bell for you to be updated for my next session. Thank you.